नमस्कार बच्चों, मेरा नाम धन्या और today we will be learning grade 11 topic general organic chemistry, and in this today's objective is inductive effect. Okay, so this is basically the electron displacement effect, and there are many electron displacement effects. Okay, like for example, inductive effect, electromeric effect, hyperconjugation, and resonance effect. All these we have to learn, but in today's video, we will be learning about inductive effect. Okay, so basically, all of them are electron displacement effects. Some are permanent, some are temporary, and in today's video, we will be learning about inductive effect. Okay, so let's get started. So basically, inductive effect is the electron displacement effect. Okay, so in this, what happens? It is the displacement of sigma electrons. So it is sigma electrons. So pi bond does not play any part here. So it is the displacement of sigma electrons towards the more electronegative atom of the sigma bond. Okay, so here the displacement is partial. So it's a partial displacement. So inductive effect is nothing but the displacement of sigma electrons towards more electronegative atom of the sigma bond. For example, if carbon is bonded to a more electronegative atom X, so electronegativity of X is more than electronegativity of carbon. So what happens? The more electronegative atom pulls the electron towards itself and develops a partial negative charge, and carbon develops a partial positive charge because the electrons are pulled towards the more electronegative X. Okay, so this is why it is called a partial displacement. Okay, now suppose there's a chain of carbon atom. Okay, so because this carbon has developed a partial positive charge, it is deficient of electron, this carbon. So it will pull the sigma electrons from the previous carbon atom, and this carbon will develop lesser positive charge compared to the first carbon atom. So let's think that this is the second and this is the third. So second carbon atom has attained a positive charge and it is deficient of electrons, so it will pull the electron pair from the third carbon atom. You can see the effect is, what is happening? There is shifting of electrons. There is shifting of electrons. Okay, and it is traveling. The inductive effect is traveling. That means because of more electronegative atom X, it pulls the electron pair towards itself, leaving the first carbon with a partial positive charge. The first carbon atom is deficient of electron, and it pulls the electron from its adjacent carbon atom. And the adjacent carbon atom, that is carbon number 2, will attain more positive, is deficient of electron, and it will attain a positive charge, slight positive charge, delta X, okay? And carbon number 2 is deficient of electron, and it will pull the electron from the adjacent carbon atom, that is carbon number 3, okay? So you can see that this is the inductive effect, and the inductive effect diminishes with distance. And this travels until the third carbon atom. Okay, it is effective until the third carbon atom. Okay, so here the X is more electronegative, so it pulls the electron pair towards itself. Okay, and such atoms are called as electron withdrawing groups. Okay, you will be learning examples of electron withdrawing groups. Okay, now let me tell you another case where so the inductive effect is effective until the third carbon atom. Okay, and it travels with distance, you can see, and it diminishes with distance. So here the carbon atom is connected to another atom Y, and here electronegativity of Y is less than electronegativity of carbon. So what would happen? The carbon will pull the electron pair towards itself, and carbon attains a partial negative charge and Y attains a partial positive charge. Again, here carbon number 1 has attained a negative charge, so it will be pulled by carbon number 2. So carbon number 2 will attain negative charge. Okay, and you can see the effect is reducing. Okay, and again carbon number 3 will pull the electron pair, and it will attain a partial negative charge, of course lesser than carbon number 1 and 2. So as you can see, the effect is diminishing as the distances increase. Okay, and here Y is donating the electron, and such groups are called as electron donating groups. So you will be learning some groups that are electron withdrawing and some groups that are electron donating. So this is the inductive effect, where displacement of sigma electrons takes place, and it moves from the, in case the atom is more electronegative, it will pull the electron pair towards itself, leaving the adjacent atom with a partial positive charge. And the effect decreases with distance. Okay, and you learned that there are some groups that pulls the electron and some groups that donates the electron. It depends upon the electronegativity. Okay, now coming to some questions. Question number 1, I will tell you some groups that are electron withdrawing and some are electron donating too. Okay, so question, which of the following is more stable? Okay, suppose there are options like this: fluorine, CH2, COO minus. Question number B, Cl, CH2, COO minus. C, Br, CH2, COO minus. D, I, CH2, COO minus. Okay. Now, students, please remember that charged species are unstable compared to the neutral compounds. Okay. So these are all charged species, you can see, but they can be stable if the charge is distributed. Okay. If the charge is distributed, they can be stable. Okay. So here, if you see, fluorine has a high electronegativity. So definitely it will pull the electron pair towards itself. So this electron cloud gets distributed, right? So the electron cloud gets distributed. So definitely First one that has fluorine is highly stable. Yes. Then the next instability is fluorine has the highest electronegativity, then chlorine, then bromine, then iodine. So because chlorine has the highest electronegativity, it will pull the electron pair towards itself, and this negative charge or this negative electron cloud, it's getting distributed. So definitely when charge gets distributed, what happens to the compound? It becomes stable. Okay, so A is highly stable. Which will be the next stable compound? Definitely the next one will be B, because B has chlorine. Here also the chlorine will pull the electron pair towards itself. So definitely there will be distribution of this electron cloud. Yes. So all these, so A is greater than B, is greater than C, is greater than D because of this order. Now all these are electron withdrawing group. So electron withdrawing group means it has minus I effect. Okay, so minus I groups are the groups who pulls the electron towards itself, or they are the electron withdrawing groups. They will pull the electrons. And plus I groups means they will donate the electron. They are the electron donating groups. So those who pull the electron or withdraw the electron towards itself, these groups have minus I groups. They are called minus I groups. And those who donate the electrons, they are the plus I groups. So you have to memorize some of the electron withdrawing groups and some of the electron donating groups. Okay, so that it is easy to solve the questions. So students, minus I effect means minus I groups means those who withdraw the electron towards itself or pulls the electron pair towards itself. So some of the groups that show minus I effect. Okay, so this order you have to memorize because these are some of the common groups. Okay, so this is the first one, NF3 group, that shows the most minus I effect, that is electron withdrawing effect. This is the second one where R refers to some alkyl group. Okay, this is the third one, NO2 group, fourth one. There are in between, there are many groups. So these are just the common ones that we are discussing. Okay, so cyanide CN group, fifth one, CHO aldehyde group. Okay, the seventh one. Okay, then the acid group, eighth one. Okay, then we have all the halogens, fluorine, chlorine, bromine, iodine. Then we have the ethoxy group. Then we have the alcohol group. Okay. So next one we have CCH2 group with a triple bond. Okay. Then we have amine NH2 group and the phenyl group that are almost similar, equal. That is why this is the equal sign. Both are similar in strength for the minus I effect. Then I have CH2. Then hydrogen is taken as a reference. So these are the groups, the order of the groups that show minus I effect, that is the electron withdrawing effect. Okay, so please take a screenshot of okay, of the order. There are many in between, so just we have taken the most common ones, okay. Now, coming to some questions. Same question, which of the following is more stable? Okay, so which of the following is stable? The first one, NO2. So you have to keep in mind the order. NO2, CH2, COO minus. B is CH2, CH, COO minus. Third one, F, CH2, COO minus. Okay, so we have the NO group, CH2CH group, and F. So if we compare, if you see the order over here, NO2 comes first, and then fluorine, and then CH2, right? So what would be the order? So NO2 will be pulling the electron more strongly, and this electron cloud get distributed. So A is more stable, then fluorine, the group that has fluorine, will pull the electron pair. So next is C, followed by B. So this is based on the -I effect group order. Okay, I hope I'm clear. Coming to the next question, which of the following is more acidic? Okay, and you have a set of compounds like this. Now, acidic order, if I say an acid has an H plus ions, right? And it dissociates to give you H plus ions and A minus ion. We can judge the acidity of an acid with the stability of the conjugate base A minus. That means if A minus ion is stable, if this is stable, that means it is more acidic. Okay, so that means if A minus ion is more stable, that means the acidic nature is more acidic nature. More acidic nature. Okay, for example, here there are 4 different halogens. And you know fluorine is highly electronegative, so it will pull the electron pair towards itself. So here there's a negative charge, here there's a positive charge, right? Here there's a negative, positive, negative, positive, negative, positive. Now here, because the fluorine is highly electronegative, it will pull the electron pair towards itself, so the charge gets distributed. So that means this ion is highly stable. So it will release the H plus ions easily. So H plus ion is released easily. So if the H plus ions is released easily, what is the nature? It is more acidic. Okay, so that means A is most acidic because here the F atom or fluorine atom being electronegative pulls the electron pair towards itself, so this negative charge is distributed. If any ion's charge is distributed, that means that ion is highly stable, or that ion is stable. And it releases H plus ions easily. So if H plus ions is released easily, that means the acidic nature is more. Okay. Similarly, chlorine is also electronegative, but less electronegative compared to fluorine. So it will also pull the electron pair and this charge gets distributed. Here also A minus ion is highly stable. So which is the A minus ion over here? This is the A minus ion. Suppose if I take this example, CH2, COO minus. This is the A minus ion and H plus. Okay, so this is how I am. Okay, so I hope you can understand. So if this A minus ion is highly stable, that means it can remove this H plus ions easily and it is more acidic. So fluorine is highly electronegative, so it is more acidic. So A is more acidic, sorry. So the compound A is more acidic, followed by B. The next electronegative atom is bromine. So that will also pull the electron pair and this charge gets distributed. So C is acidic, the next acidic is C, the last one is D. Okay. So we can judge the acidity of the compound. Okay. So we can easily say, before we make a conclusion about it, here you can see the order of minus I effect: fluorine, chlorine, bromine, and iodine. This is the order, right? So we can say more minus I effect, more is the acidity. Why it is more? Because of the stability of A minus ion. Okay, why A minus ion is stable? Because the charge gets distributed. If the charge gets distributed, the H plus ions can be removed easily. I hope it is clear. So you can, So you can keep in mind the statement, more minus I effect, more is the acidity. Okay. Into the next question, which of the following is more acidic? There are four options here. In the first option, you can see there is no minus I group. In the second one, there is one minus I group. In the third one, there are two minus I groups. And in the last one, there are three minus I group. Okay, so if minus I group is there, if there are more minus I group or there are minus I group, it will make the conjugate base or conjugate species. This is the A minus species. Remember HA. So this is the H plus ion. This is the A minus, the conjugate base. It will make the conjugate base more stable and more is the acidity. So we just learned a while ago. So if more the number of minus I groups present, more is the acidic nature, because it will lose the H plus ions more readily, because this conjugate base A minus is more stronger or stable. Not strong, sorry, it's stable. Okay, so here who has more number of minus I group? D has the most number because there are three minus I groups. You can see here, three chlorine groups. Who is the next one? In the C option, there are two minus I effect groups, that is two chlorine groups. So D will be more stable or more acidic than C. Next one is B, because it has one chlorine group. And here the least acidic will be A because A doesn't have any minus I effect group. Okay, I hope it is clear. Coming to the next question, there are three options over here. As you can see here in the first option, there is no minus I group. In the second one, there is one minus I group. One is there, one chlorine atom is there. In the third one also one is there, but you can, if you compare the second one with the third one, what about the distance? It has become more far. There is one minus I group, but far away from the hydrogen ion, right? So definitely A will be least acidic because it has no least acidic. Why least acidic? Because there is no minus I group. So A is least acidic, so we have to compare between B and C. So between B and C, B will be more acidic because it has minus I effect and it is near, right? So B will be more acidic, followed by C. C has one minus I group, though it is far, but at least it has one minus I group, though it is far away from the H plus ion compared to B. Okay, the least acidic is A. So from here we can conclude that those species that have stable minus I or those species that have minus I effect group will be more acidic. Why? Because the conjugate ion A minus is more stable and it will remove the H plus ions from the acid more easily. I hope I'm clear. So the C option also has minus I effect group, but it is far away from the, it is a little bit far away from the H plus ion group compared to the B option. That is why if we compare B and C, B is more acidic than C. I hope I am clear here, right? Now students, next coming to electron donating group. That is the group showing plus I effect, those who donate the electrons. Okay, so this is the order. Okay, CH2 minus is greater than NH minus, is greater than O minus, is greater than COO minus. Then next is the tertiary alkyl group. This is tertiary alkyl group, carbon surrounded by 3 methyl groups, and methyl groups are electron donating group. So there is accumulation of negative charge on the carbon atom. So next is secondary alkyl group having 2 methyl group, you can see. So they donate the electrons towards the carbon atom. Next is the primary alkyl group that has 1 methyl group. Okay. And this is also primary and it is called just methyl group. Okay. So this is the order of the plus I effect showing group, those who donate the electrons. Okay. So how plus I effect group? So this you can take a screenshot of the plus I effect group. Here also in between, there are a lot of groups in between. So just taking some important groups. So if needed, when during the questions, we will include some more information here. Okay. So how does plus I effect group or plus I groups affect the acidity? Now, here, if we say, so for minus I effect group, those who have minus I effect group, the acidity will increase. Now, acidity order. Suppose if I take an example for a tertiary alkyl group or tertiary alcohol. Okay. Next is secondary alcohol. Secondary means the carbon atom surrounded by two methyl group or two alkyl group. Okay. So OH. CH3, CH2, OH. D is CH3, OH. Okay. Now, over here, if we say that in the first case, there are three methyl group, all these methyl group will give the electrons towards the carbon atom. Here, this is minus and this is positive. So, here, because there's already accumulation of a negative charge on the carbon atom, this is A minus group, this is H plus group, right? So, already there is a lot of negative charge on the carbon atom. So, here, minus I effect is more, sorry, plus I effect. This is plus I effect, right? Because they are electron donating. So plus I effect is more. So there is accumulation of more negative charge on the carbon atom, which will make the A ion unstable. If this is unstable, it will not lose the H plus ion so easily. So this will go to the oxygen. The negative charge is pulled by the oxygen ion. So electron density is more on the oxygen. So this will make the A ion more unstable. So it will not lose the H plus ion more easily. So if it doesn't lose, then it is least acidic. Because acidity means those substances that loses H plus ions more easily. Over here there are two electron donating group, methyl group. Yes. So here also the A minus ion. This is the A minus ion. Remember HA. We just saw a while ago, HA means A minus plus H plus. So this is the H plus and this is the A minus ion. So here also there is plus I effect is more if you see, and more electron density on this oxygen, which will make the A minus ion unstable, but less unstable than the first one. Okay. Coming to the third one. Here there is plus I effect. Yes. But if we compare C and D, if you see, methyl group has, if you see the order, methyl group has the least plus I effect. So if it has the least plus I effect, that means plus I effect is least. So the electron donating tendency is there, but less compared to others. So that means this A minus ion is stable. If this is more stable, that means H plus ions is lost readily. So D, this will lose H plus ion easily. Why? Because this A minus ion is stable. Okay. So here D is more acidic than C. Okay. Then next is between A and B, who is more acidic? B is more acidic because they are less electron donating group. There are only 2 methyl groups here in B. So it is showing less plus I effect compared to A. A is least acidic. If it is least acidic, that means it is more basic. To make things simpler, we can say more plus I effect More plus I effect means what? Lesser acidic nature. So if minus I effect means more minus I effect, more acidic nature. More plus I effect means more lesser acidic nature because the A minus ion is not stable. So it will not lose the electron or H plus ions readily. Okay. So this is how plus and minus I effect the acidity. I hope I'm clear. Okay, now let's practice some examples. So this was discussed before. So we will be discussing about the acidity order, okay, based on the plus I and minus I effect. Now, coming to the next question. The question is same. Order of acidity. Acidity order. A, COOH. B is CH3, COOH. And C is Cl, CH2, COOH. So here, this is the ion, this is H plus. This is the ion, this is H plus. This is the ion, this is H plus. Now if we compare A, B, and C, A has plus I effect group. Yes, this plus I effect group is there, right? If you see over here, it has a secondary. This is the secondary, right? Carbon surrounded by 2 methyl groups. This is secondary, so plus I effect group. Here also, plus I effect group is there. So if plus I effect group is there, that means the acidity is lesser. But in this case, you have an electronegative atom, chlorine, that will pull the electron towards itself. It has minus I effect group. So if minus I effect group is there, that means the A minus, the anion is more stable. This charge is distributed. So that means this is more, and the H plus ions is lost readily. So it is most acidic. So definitely C is more acidic. Now compared to B and A, who has more plus I effect? Here there are 2 methyl groups. In A there are 2 methyl groups, right? So definitely it will be least acidic. More plus I effect group, least acidic. Right. Now, if you see the order also, the secondary is greater than primary. So in this is the secondary and this is the primary. So definitely secondary is less acidic compared to primary. So next our order will be B and then A based on the order. I hope I'm clear here. Coming to the next question. If you see there are two acids, this is the formic acid and this is the acetic acid. Okay, the common names. Okay, here also, if I take the A minus ion of both of them, okay, so removing the H plus ions. Now here, if you see, CH3 has plus I effect. So if plus I effect is there, that means less acidic. So here there is no effect because hydrogen is just taken as a reference. So comparing A and B, A is more acidic than B, right? Because here there is no effect. Here there is plus I. If there is plus I effect group, it will reduce the acidity, less acidic. Okay. Now, coming to a similar question here. Which of the following is more acidic? There are three options over here. Now, if you see here, there is plus I effect group, right? So CH3, COO minus. So here, this is a plus I group, right? So plus I group means it is less acidic, right? Now let's see the other options. Here in B, chlorine has, so I will just write COO minus, right? Now this is the A minus ion. Now this is chlorine has minus I group. Now always remember CH2 has some plus I group, okay, some plus I effect. It's an electron donating group. Now, if we compare, here there is minus I effect because of chlorine, here there is plus I effect because of CH2 group. Right. Now here the net effect is minus I effect will dominate. So the net effect is minus I effect will dominate over the plus I effect. So that means if minus I effect will dominate, that means there is some acidity. Now, here in the third option, there is CH2 COO minus. Over here, OH, if you see, OH has minus I effect and CH2 has plus I effect. Now, here the net effect is the plus I effect is dominates. So the net effect is plus I effect. Okay. Now, if we see the minus I effect chart also, which I had written before, minus I effect chart, if you see chlorine dominates over OH, right? So that if chlorine dominates over OH, that means who will be more acidic? Definitely the compound that has chlorine will be more acidic compared to the compound that has OH. So definitely who will be more acidic in this case? B will be more acidic, followed by C. Why? Because in the chart, chlorine is more plus I effect group than OH group. Okay. Then the least is A because A has plus I effect group. I hope I'm clear here. Right? Now, coming to the next question. So always you have to memorize the chart. Okay, remember the chart. That is very helpful. Coming to the next question, same. The question is the same. Which one is more acidic? The first, if we see formic acid, it's COOH. We just wrote formic acid a while ago. B is acetic acid. Also, we wrote before. C is ClCH2COOH. Now, if you see here, there is no effect, no I effect. Here, there is plus I effect. And here, there is minus I effect. But at the same time, there is plus I effect because of the CH2 group. And also the distance. But the net effect is that the minus I effect of chlorine dominates. So C is more acidic than A because my plus I effect means less acidity compared to no I effect group. So, which is A is more acidic compared to B. I hope I'm clear here. Plus got deleted when I rubbed. So we just learned that when there are more plus I effect group, it is less acidic. If it has minus I effect groups, then that substance is more acidic. Okay, so this plus got rubbed sometime before. Okay, so this is what we learned before. Now, acidity means any substance that releases H plus ions in aqueous solution. Now, this constant acidity constant Ka is given by the concentration of H plus ion, A minus ion, and Ha. Now you can see this Ka is directly proportional to concentration of H plus. More H plus ion means more value of Ka. So acidity is more. Okay, so as Ka value increases, acidity increases because the H plus ion, that means H plus ions is more. Now based on this, we have, you don't have to memorize anything about Ka or anything. Just you have to remember the list of substances that have the acidity order. Like sulfonic acid is more acidic than formic acid, which is more acidic than benzoic acid, which is more acidic than alkyl acid. Okay, then which is more acidic than carbonic acid, then alcohol, then water, then this is the normal alcohol. Then this is the acetylene, then ammonia. Okay, then you have ethylene. Okay, and then you have ethane. So this is the acidity order that you must remember. Okay. Now, coming to a question, if you have, suppose, water, B is C2H5OH, ethyl alcohol. Then you have CH triple bond CH. Okay. You have to tell the acidity order. Okay. Now here, if you see the list, there is water, then you have ethyl alcohol. Okay, so this is R stands for any alkyl group. Okay. Then you have CH triple bond, CH, acetylene. Okay. So that means water, which is A, is more acidic than B, which is ethyl alcohol, which is more acidic than acetylene. Okay. But here there's a small, this is correct, but in case of methyl alcohol, this is ethyl alcohol, this is correct, this order is correct, but the exception is that methyl alcohol will be more acidic than water. Okay, so water is more acidic than all alcohols except, so water is stronger or acidic than all alcohol except methyl alcohol. Okay, so this exception you have to note it down. Okay, I hope I'm clear. So this order also you have to keep in your mind. Yes. Okay, and also please keep in mind this because this plus was removed when I was rubbing some of the things. So if plus I effect is there, it is less acidic. If minus I effect is there, then it is more acidic. Plus I effect, less acidic, minus I effect, more acidic. Okay. Now, coming to some more questions. Suppose you have, same, you have to guess the acidity order. Formic acid. B is acetic acid. C is benzoic acid. And D is alcohol. Phenol, rather. Okay. So definitely if you see the order, formic acid is definitely more acidic because CH3 has plus I effect. Yes. So definitely formic acid is more acidic than acetic acid. Then compared to but if you compare it with benzoic acid, right? So we have, if we compare with benzoic acid, so formic acid, if you see, it is more acidic. Then next one is what? Benzoic acid. Then acetic acid. So R can be replaced by CH3, right? And then the next one is phenol. So definitely, first one is acetic acid, then benzoic acid, then is acetic acid, and then is phenol. So if you remember the order, it becomes easy to answer the questions, right? So coming to the next question, same, the acidity order. Okay, so if you have the list, it becomes easy. Coming to the next question, if you have acetic acid, it doesn't have any plus I or minus I effect, but CH3COOH has plus I effect. This is benzoic acid. And D, we will place something with minus I effect. Okay. Okay. So here there is plus I effect And here there is minus I effect. And we already know plus I effect means less acidic. Minus I effect means more acidic. Right. Now, here there is no effect. So definitely, because of the minus I effect, D has become most acidic. Right? So now we have the comparison between A, D, and C. Now here, we already know, here we can check the list. Formic acid, benzoic acid, and acetic acid. So definitely you can see over here, formic acid is most acidic, then benzoic acid, then acetic acid, right? So next one will be who? Formic acid is A. Next one is benzoic acid. And the least acidic is acetic acid. Okay. So why we have placed D before? Because D has iodine, which shows minus I effect, which is more acidic. I hope I am clear. Okay. So if you know the list, it becomes easy to compare the acidity. Coming to a similar question where we have benzoic acid. In the second one, we have NO2 group in the benzoic acid. In the third one, we have methyl group in the benzoic acid. Now, NO2 group means it adds to minus I effect. And methyl group means it adds to plus I effect. And you know, plus I effect means those who have plus I effect, that will, the acidity will be less acidic. Minus I means it will be more acidic. So, over here there is no such groups present. Okay. Now, here, benzoic acid, then here, phenol. Please remember that phenol is a, so if we compare, here there's a phenol with a nitro group, right? So phenol that has a nitro group means that has minus I effect. Although we said that minus I effect means the acidity is more. But here phenol is a weak acid. Okay. Over here, if we check also, see, phenol comes after, much after benzoic acid. See, phenol comes much after benzoic acid. If you compare phenol and benzoic acid, phenol comes much after benzoic acid. So phenol is a weak acid. Now, knowing all these informations, okay, definitely B is least acidic because of the phenol group. Okay, although nitro has minus I effect, it is acidic, but still phenol is a weak acid. Keeping all these in mind, comparing A and C, who is most acidic? A, because here there is plus I effect that reduces the acidity. Then I have C, then I have B. I hope I'm clear here. Okay. Now, coming to the next question. If I have phenol, nitrophenol, yes, and here there is also nitrophenol, but in the meta position. Okay, so we already discussed in the previous video, if I have a group over here, OH group, or any group here, this is the ortho, meta, para position. Right. Now in the C question is also a phenol with a nitro group at two positions, meta and para position. Now we already know that the I effect or minus I or plus I effect depends on the distance. Right? Here NO2 group is minus I group. Okay. Here there is one group, NO2 group present. Here also one NO2 group present. Here there are two present, two groups present. Now here, please remember one information. NO2 group is in NO2 or minus I effect group is in para position. More is the effect. More is the effect. Okay, so here you can see the first one. It is in the para position. So definitely it is strong acid. And it's minus I affecting group. It's in the para position. Of course, phenol is a weak acid. But still comparatively, because all are phenol substituents, right? So here, comparatively, NO2 is in the para position. So definitely it will be strong. Okay, compared to here it is in the meta position in B. But in C, you can see there are two groups, one in para and one in meta. There are two groups present. Yes. So definitely C is more acidic than A and then B. Okay. Because if the minus I effect group is present in the para position, it makes it more acidic. So definitely B is least acidic. Okay, so we have to compare between A and C because in A and C, the nitro group is there in the para position. But C has the additional advantage. It has two minus I group. So two minus I groups are there. So that means it is more acidic compared to A and then B. Okay. Coming to the next question. If I have FCH2 COOH, B is Cl CH2 COOH, C is Br CH2 COOH, D is I2CH COOH. Now all of them are minus I effect group, right? All of them are minus I groups, minus I group, where fluorine is more electron withdrawing effect than chlorine, then bromine, then iodine. Minus I is nothing but electron withdrawing group. Yes. So here you can see all of these are one electron withdrawing group, but in the last one D, there are two of them, two groups present. So whenever there are two groups present, more the number of minus I group present, more is the acidity. So definitely D will be the most acidic. Why? Because there are two groups present. The rest of them follow the normal order where fluorine is greater than chlorine is greater than bromine because all of them have single minus I groups. So next is what? A is greater than, more acidic than B than C. Okay, why D is most acidic? Because it has two minus I groups present that makes it most acidic. Okay, I hope I'm clear here. Okay, let's come to a similar example like this. Okay. If I have CCl3COOH, HCF2COOH, Ci3COOH. So here there are 3 electron withdrawing group present. Here there are 2. Here there are 3. Right. So here there are 3 groups present, minus I group. Here there are 2 group present. Here there is 3 group present. See, the iodine is 3 groups, right? So definitely A and C are more acidic than B, because B has only 2 groups present. Now, among A and C, who is most acidic? A, because chlorine is more acidic than, or chlorine is more electron withdrawing or more electronegative than iodine. So A is more acidic than C, then B, because B has only 2 minus I group present. Okay. Coming to the next question, if I have 2 compounds, okay, in the first one, the negative group charge is on oxygen and hydrogen is released here. And in the second one, the charge is on the hydrogen here, NH here, and 1 hydrogen is released. The charge is on nitrogen here, and hydrogen is released. Okay, and here, if you see, there are 2 plus I effect group, CH3, and here also plus I effect. So the plus I effect is more. Okay, here only 1 group, here also plus I effect is there. But over here, you have 2 plus I group. So A is less acidic than B, because if I have plus I effect group, the acidity is less. Okay, and in the second one, I have only 1 plus I effect group. So here, that means the A minus ion is more stable, right? So that is why A is more, or A is less acidic than B. But if you see over here, the charge in the first one, the negative charge is on the oxygen atom in the first case. In the second case, the negative charge is on the nitrogen atom. Okay, so that means the atoms are different. Okay, when in such cases, when the groups are different, okay, or when the atom is different, or negative charges on different atoms, then we follow the rule. This is a very important rule. Negative charge on more electronegative atom is more stable. So this part is the A minus ion. That gives stability or acidic character to the acid. So this part is A minus, right? So if the negative charge is on more electronegative atom, then that means that atom is more stable. Okay, or that A minus ion is more stable, or that species is more stable. Okay, so that atom or that species is more stable. For example, in the first case, I'll just rub these. Oxygen is, the electronegativity of oxygen is more than that of electronegativity of nitrogen. So definitely here, the species, the A minus species of the first one, A, is more stable than the A minus species of the B compound. So definitely this is wrong. A is more stable than B. So negative charge or more electronegative atom is more stable. When do we look at this? When the negative charge is on two different atoms. Here, two different atoms. So definitely we check the electronegativity. I hope I'm clear. Okay. Coming to the next question. CH, we have to check the electronegativity of acetylene. And CH3, CH3. Okay, so just a note, if the triple bond is more acidic when it appears in the terminal position. Okay, for example, if I have just a note before we start doing the question, CH3, C, triple bond C, CH3. Terminal means appearing at the edge or the end. Here it is not terminal. It is not terminal. So if it is not terminal, that means this is not acidic. But in this case, here there is no other choice. This is the terminal one. Okay, there is no atom on either side. So definitely this becomes the terminal one. So A is more acidic than B than C. Okay, so we come to a conclusion, terminal alkynes, I'm talking about the triple bonds, are acidic. So terminal alkynes are more acidic, then double bonds are acidic than the single bonds. I hope I'm clear here. Okay. Now, the reason for this is when there is triple bonds. Okay. Whenever there is triple bond, it is sp hybridization for triple bonds. When it is double bond, it is sp2 hybridization. And when it is single bonds, it is sp3 hybridization. Okay. And for S character, for sp, it is 50%. 50% S and 50% P. For sp2, the percentage is 33, and for sp3, I'm talking about the S character, okay? 25%. So as S character increases, okay, electronegativity also increases. So if electronegativity increases, what happens? The ion becomes, or the species becomes more stable, and it can lose electrons easily, or lose H plus ions easily. So it becomes, species becomes more stable, and it loses H plus ions. If it loses H plus ions means it is acidic. So acidic character depends upon the S character also. I hope I'm clear here. Okay, and also terminal alkynes. If it's a triple bond, it should be a terminal alkyne, right? Coming to the next question. CH, triple bond CH, B is CH2, double bond CH2. C is CH3, ethane, CH3, CH3. This is ethene. Second one is ethene. First one is acetylene. Sorry, ethyne. First one is ethyne. Second one is ethene. Third one is ethane. Okay. And D is benzene. Okay. Now, if we check the chart, okay, if we check the chart over here, just wanted to add the benzene. The benzene comes before ammonia. Okay, so we will place benzene over here. It comes before ammonia and CH2, CH2. Okay. Sorry, I placed it in the wrong position. So benzene, we will place it, I'll write with red because I'm just adding this one. So benzene, we will place it here, C6H6. So after ammonia comes benzene. After benzene comes this ethene. Okay. So as I told you, there are a lot of groups that comes in between. Okay. So we are just taking the important ones. Okay. Now, writing the acidity order. Okay. So definitely this is the terminal triple bond, alkyne. So triple bond is acidic, alkyne. The terminal alkyne is acidic. Then definitely C is least acidic because the S character is less. Then among B and D, benzene and ethene, who comes? Benzene comes. Because we just saw in the list that benzene comes before ethene. Then B, then C. I hope I'm clear. So that is why certain compounds or certain species, the order you need to memorize so that it's easy to write down the order. Okay. Coming to one more question, the hydrides of period 2, comparing the hydrides of period 2, which is more acidic. Okay. So if we have methane, if it loses one H plus, it becomes CH3 minus. If ammonia loses one, it becomes NH2 minus. If water loses one H plus ions, it becomes OH minus. If HF loses one hydrogen, it becomes F minus. Now, when the atoms or when the negative charge is on different atoms, we look at the electronegativity. So who is the most electronegative? Fluorine. So it is more stable. So definitely D is more acidic, right? And next is oxygen. Then nitrogen, and then carbon. So we write the order like this. A is less than B, is less than C, is less than D, because the negative charge is on different atoms. In order to compare the acid strength, we look at the electronegativity of the atom on which the negative charge is present. So whichever is more electronegative, that will be more stable, or that species will be more stable. Okay. So this is it for today. Have a great day. So thank you. Have a great day, students.